This is William Tomos Edwards from Bright Studies, and I want to show you guys this new technique for solving for oblique asymptotes that's totally easy. So as you guys know, when you have to solve for the oblique asymptote for a function like this, a function like this is always going to have an oblique asymptote where the term in the numerator to the highest power is just one greater than the term in the denominator to the highest power in the denominator, right? The term in the numerator raised to the highest power is just raised to a power greater than one, and the term in the denominator raised to the highest power, right? Something of this form is going to have an oblique asymptote. You're going to solve for it with polynomial long division or synthetic long division. Well, I'm here to tell you, you don't have to do that. I'm here to tell you a shortcut that you can use to easily solve for the oblique asymptote for any function like this. So as we can see over here, you know, the oblique asymptote is going to be of this form. It's going to be a linear equation. Solving for x is the easy part, right? It's simply the coefficient on the highest term in the numerator divided by the coefficient of the highest term in the denominator, right? The terms of the highest powers, right? You multiply that by x. That's the slope of the oblique asymptote. Solving for b, the intercept on the oblique asymptote. Solving for the y-intercept, that's the hard part. B is the hard part. But I'm here to show you guys this handy dandy table right here. Now it's just going to be totally easy to solve for b, for the intercept, for the oblique asymptote. We don't need to do any long division at all, because b is going to be equal to one of those. So this is going to take some memorization, or maybe you guys can have this on a formula sheet, maybe you can have it on a cheat sheet in front of you, or it's going to be some memorization to get some muscle memory. But that won't take long, and you'll get the muscle memory. And you can use this to easily solve for the oblique asymptotes. So let's look at this example here. Let's do this example. What's the oblique asymptote going to be? Okay, well, it's going to be 9 over 2x. Okay, and then we're going to look at it. One thing we're going to look at here is this k1, right? And what's the k1? It's that one, okay? It's referring to the exponent, the power for the second highest term. The term raised to the second highest power in the numerator. And so in this case, it happens to be the k subscript 1 is 2. So the k subscript 1 is 2, so that is not equal to n minus 1. And in this case is 10, right? So we're not going to look at that. Okay, but then we're going to look at k subscript 2. Okay, k subscript 2. What's that? The k subscript 2. Well, that is indeed referring to the term raised to the second highest power in the denominator. And so for k subscript 2 in this case, it's 8, right? And so 8 is in fact equal to n minus 2. Okay, so thus we know what we're going to do. K subscript 2 in this case is 8. That is 10 minus 2. So that's going to give us minus b subscript 2, right? In this case, 3 times a subscript 1, in this case, 9, over a subscript 2 squared. So that's 2 squared, that's over 4, right? Okay, great. We can simplify that as minus 27 over 4. Awesome. So let's see here. Let's see if this is true. 9 over 2x minus 27 over 4. Okay, let's go to Symbol Lab. We've got it here. We're going to try and do it. That's the rational function. There it is. Well, Symbol Lab can't solve it. It can't crunch through all those numbers. It doesn't want to do it. Okay, fine. Let's go to Desmos. At Desmos, you can see here, I've graphed the function, the rational function, and then I've graphed the linear equation that supposedly approximates it. Okay, you can see this here, and wouldn't you know it, it's absolutely correct. We can zoom out and we can see it, and we can see, yes, that is indeed the oblique asymptote for that function. Wonderful. So perfect. So that's it. That works. Okay, great. Okay, let's go back to it. So the beauty of it here is you don't have to worry about the other terms, right? When I show the abstract version, right? When I show this abstract version of what the function is going to be with an oblique asymptote, the rational function, when I show it there, we don't worry about some of the terms in the numerator or the denominator. Right? We just have that dot, dot, dot to say however many terms is there. We don't worry about them. We don't need to, because the only thing that matters is the term to the highest power in the numerator and denominator. The only thing that matters is the terms of the highest power and the second highest power in the numerator, and the terms of the highest power and the second highest power in the denominator, right? The only thing that matters here is the terms being raised to the highest and second highest powers in both the numerator and denominator. So what that means, in our example here, all we have to worry about are those 4 terms, right? The 9x to the 10, the minus 4x squared, the 2x to the 9, the plus 3x to the 8. That's all we have to worry about, okay? Those other ones I just circled, we don't even need to worry about them. We don't need to care. They can't dictate anything about the oblique asymptote. Okay, wow, that's great. So let's try another one. Let's see how easy this can be with some different examples. Okay, so we'll erase this example. We'll try another one. So let's see. Let's try 27x to the 7 minus 6 over 3x to the 6 minus 2. Means our oblique asymptote is just 27 over 3x equals 9x. Okay, that's easy enough. That's easy enough. Okay, cool. So let's take a look at that on Symbol Lab then. Okay, Symbol Lab's taking a minute to do it. Wow, I'm gonna guess Symbol Lab has got some glitch going on the server side if it can't solve this today. Let's try and take that to Desmo, see what happens. Did that work? Great. So we'll just get rid of those for a minute. Okay. Okay, that's an interesting function. And so what we'll look at for the oblique asymptote is just going to be 9x. And yeah, sure enough, that fits. Okay, great. Maybe Desmos is going to be our best friend today. So let's try another one. Okay, so I'm going to show you guys some we've got to watch out for, kind of related to what I was saying. So let's say we try this one. Let's say we're going to try okay. How about this? Okay, well, this is where we got to watch out, because now that's 2x, okay, to the 0. So now it does fulfill the criteria that k subscript 2 equals n minus 2. It does indeed, because n in this case is 2. So that's where we got to watch out. So now we know our oblique asymptote is 5 over 2x minus 2 times 5 over 4. So that equals 5 over 2x plus 10 over 4. Okay, awesome. So let's go to Desmos, see what Desmos can do. Beautiful. Yep, that works as always. So that's just the tricky one we got to watch out for. Where technically, this one is indeed, right, the 2 minus 2, or it fulfills the n minus 2 criterion, looking at the table. So that's just one to watch out for.